Okay, for this one we have cosine of 2 times an angle. Again, I want you guys to recognize that when you see the inverse trig function, that's just an angle, so we can call that theta. So really I have cosine 2 theta. Cosine 2 theta can be written in 3 different forms, but the one that I use as my default usually is cosine squared theta minus sine squared theta. You could also do 2 cosine squared theta minus 1 or 1 minus 2 sine squared theta. So in order to evaluate this, I need to find the cosine of theta and the sine of theta. So I'm going to draw a quadrant triangle. It says the cosecant is equal to negative 11/6. Cosecant is the reciprocal of the sine or function. And the sine function for inverses goes in quadrant 1 and quadrant 4, from negative pi over 2 to pi over 2. So I'm going to draw this in quadrant 4. I'm not going to draw it to scale. And I'm going to call this theta. And so the cosecant is negative 11/6, which means the sine is negative 6/11. And then I can use Pythagorean theorem to figure out the rest up here. So this is going to be the square root of 11 squared, which is 121, minus 6 squared, which is 36. So that's going to be square root of 85. Okay, so then I can evaluate cosine squared theta. So cosine of theta is root 85/11. And sine squared of theta is negative 6/11, all squared. So evaluating that, I get 85 minus 36 over 121. Which is 49/121. And that's it for this one. So again, recognizing it as cosine of 2 theta. That's the trick.